All right, in this example, we have a student who's created some new sort of rock string weapon. So it consists of a 0.5 kilogram rock with a string attached to it. It's really important to note that this is swung in a vertical circle. So it's swung in front of them up and down, okay? As opposed to horizontal parallel to the ground. So it's vertical, perpendicular to the ground. The radius of the circle is 0.6 meters, and at 4 meters before releasing it, or 4 meters per second of velocity before releasing it. The string's got a tensile strength of only 15 newtons. So the question here is, will it break and will he end up hitting himself in the head, or where will the rock go? So essentially what we're determining is what is the FT, or the tension, in the string at the top of the rotation and at the bottom. So we're going to draw one diagram, but we're going to put the rock in there twice. So if we draw a circle, we'll note that we can see, we'll draw a circle something like this. And what we'll do is we'll put the rock at the top. And when it's at the top, going down to the middle, we have an FG, because again, this is vertical circle, and then some tension pulling towards the middle. When the rock is at the bottom, again, it's, we're going to identify the middle part of the circle here, but we have an FG going down, and we also have our tension in this case going up. So here we're going to try to take a look at what the tension in the rope is going to be at each individual point. So let's do the top first. So at the top, we have our centripetal force equal to our force of gravity plus the tension in the rope. We can rearrange this to solve for tension is Fc minus Fg. And then by plugging in some of the equations we know, we're left with this. This is perfect because we have all of this information. Our question gives us m, which is 0.5, v, which is 4, and r, which is 0.6, and it gives us m again, 0.5, and of course we know g, 9.8. So we can solve for that and get 8.4 newtons. Since this is less than the tensile strength of the rope, we're okay at the top. The rope will not break. Let's go again to the bottom. And we're going to solve this using a similar equation, but the difference here is that we need to note that t and fg are in opposite directions. So we need to somehow account for that in our equation. So I'm going to say since t is going towards the middle, it's positive. Fg is in the opposite direction, so it's negative. That leads us to having t equal to fc plus fg, which you should note is slightly different than our previous equation. Since we already have the values for fc and fg here, when you add them together, instead of subtracting them, you get a value of t being equal to 18.2 newtons. And since this is greater than our tensile strength of 15, we can say that the rope will break as it comes towards the bottom of its rotation.